we're going to take today and finish this up. Tomorrow I'll most likely do a review day before we move into section 3, which is actually the last section out of chapter 6 that we're going to cover. So, we're still solving equations, and we've got several different techniques to look at. You know, some of them only have one trig function, so we just have to get it by itself. Sometimes we have to use one of the identities from our flip charts. Sometimes we had to factor. What would we do on this kind of problem? Cosecant x.
Oh,
We could factor that out. Now what would we do? Okay. Cosecant equals 0. If you don't like cosecant, you could think about its reciprocal. Reciprocal of cosecant is sine. What's the reciprocal of 0? Undefined. Is sine ever undefined? No. So can this happen? So we just ignore that one. All right, over here, when is tangent positive? Reference angle. When is tangent the square root of 3? We are in radians. What's your hand trick? Tangent, square root of the top over square root of the bottom. 60 degrees, which is pi over 3. All right. So pi over 3 in quadrant 1 is pi over 3. What's pi over 3 in quadrant 2? It's not. That's a 3. So it should be a 4 pi over 3. Thank you. Did I say 3 and write 2 at the beginning? Okay. Is that one all right? Okay, this one's a little different. We have a fraction. What would you guys recommend to start? Do you like fractions? Can we get rid of it? How? Just multiply by the entire denominator. Cotangent x plus 3. So 1 times anything is that thing. So now, what would I have to do? We need it all on one side. Then what do we do? Alright, so So we need two things. Multiply to -6 and add to -1. Okay. We started by multiplying by 2, so now we divide by 2. So we get 2 cotangent x minus 3 cotangent x plus 1. Now what? Mhm. All right. Do we know when cotangent is 3 over 2? Okay. If you don't like thinking about cotangent, that means tangent is 2/3. So we can get our quadrant. Tangent is positive in 1 and 3. Reference angle. I need to know when tangent is 2/3. Since that isn't one I know, I have to use my calculator. My directions said 0 to 360, so put it in degree mode. And then you can do tangent inverse 2/3. Let's just do 2 decimal places. You don't need to get too crazy with these. So, in quadrant 1, the angle and the reference angle are the same. How do I put this in quadrant 3? Add 180. So you 213.69 degrees. This one. What would we do with that? What quadrants is cotangent negative in? Reference angle. If cotangent is -1, that means tangent, the reciprocal, is also -1. So when is tangent 1? 45 degrees. So 45 degrees in quadrant 2. So 180 minus 45 is 135. In quadrant 4, 360 minus 45 is 350. And I haven't really been doing a lot of this, but just like any other equation you solve, you can check these just by plugging them back into the original problem. Can we handle a hard one? I think we can. Let's try it. Let's do. We have to multiply it out because it's not equal to 0. So even though it looks like it's factored, that doesn't help us. We have to multiply out. And then what should we do? Set it equal to 0, so it's bring the 1 over. Then what? Flip and slide. So what multiplies to 2 and adds to 2? Nothing. So this doesn't factor nicely. What do we do with things that can't factor? Box method and slip and slide are really kind of the same. So this didn't work, box method won't either. Quadratic formula. We could do the quadratic formula with a trig function. Isn't this fun? Okay, so quadratic formula. We usually say x equals, but here my variable, this is like cosine theta, equals opposite of b, -2, plus or minus the square root of b squared minus 4ac all over 2a. So this is maybe why I shouldn't make up problems, but we can work it. All right. What do we get under the radical? And you get 4 minus 8, which is -4. What's the square root of -4? 2i. Can our trig functions equal imaginary numbers? No, so what does that mean? See, it wasn't so bad. Now, if you hadn't gotten that, if you got a number, then you would use your calculator and do cosine inverse to get your reference angle. So then you would just finish it like always. Questions here? So, a couple things we're going to do. Before we do anything else, I'm going to give you a blank unit circle, and I want everyone to practice filling out, because I've noticed you guys are relying on that a lot, which is great, but I want to make sure you still know how to fill it out. So let's practice one of those.